Hi, my name is Jenna and this is part of the Pimp My Bike series. In this video, I'm going to show you how to build a speedometer and odometer. For more information, feel free to check out my website, jdubois.com. Okay, let's start by talking about materials. You have a variety of options when it comes to selecting an LCD. The standard 16 by 2 character LCD is the most basic. It starts at $10. I purchased the RGB backlit LCD. For $3 additional, your speedometer/odometer can be used at night. To measure speed and distance, we're going to use a reed switch. You're also going to need a 10K resistor, male-female connectors, and jumper wires. Cool! Here's the speedometer-odometer in action. Holding down the right push button turns on the backlight and cycles through colors. To turn off the backlight, you simply hold down the push button again. Pressing the left LED push button clears the odometer. By default, speed and distance are reported with metric system units, but to report miles instead of kilometers, you can set the Boolean variable metric to false. You'll also need to change the variable wheel C to the circumference of your bike tire in centimeters. Alright, part 1, the LCD. I just can't say enough about Adafruit Industries. They've done an amazing job of making electronics projects accessible. I definitely recommend checking out their character LCD tutorial, which contains all the information you'll need to get started with LCDs. I won't go into too much detail because this is covered in the tutorial, but the first step is to solder the header pins to the LCD. There are 2 rows of holes, but you only need to solder the header pins to the top row. Next, you attach the LCD to the project box and you begin wiring the LCD. Since wiring is already covered in the Adafruit Industries tutorial, I'll leave it as an exercise to the viewer to read over these instructions. For additional help, you can also refer to the Pimp My Bike Arduino sketch. There's a comment below the Pins to Set section which tells you how and where to connect each LCD pin, assuming you're using the backlit RGB. Okay, now let's talk about the component we're going to use to measure speed and distance. The reed switch is just like the normally open push buttons used for the turning indicators. The switch is open by default, but in this case, the switch is closed in the presence of a magnetic field. When you bring the magnet within a centimeter of the switch, the voltage read at digital pin 2 will be high, or 5 volts. By attaching the magnet to the spokes of your wheel and the reed switch to the wheel fork, we've effectively created a switch that is closed every time the wheel completes a full rotation. If we know the circumference or diameter of the tires, we can do a little math to calculate the speed or distance traveled over time. Wiring the reed switch is going to be just like wiring the LED push button. One lead is connected to 5 volts and the other lead is connected to a 10K resistor, which is grounded. To sense if the switch is closed, we use an analog or digital input pin on the Arduino. In this circuit diagram, the blue jumper connects the Arduino to the same breadboard row as the resistor and reed wire. Just like for the turning indicators, we build this circuit on a proto or screw shield and connect the reed switch to the shield using male-female connectors. In this case, we'll only need 2 of the 4 wires on the cable. You can ignore or clip the wires that aren't in use. And that concludes this part of the project. Thanks for watching. Feel free to check out my website, jdubois.com, for additional information.